So thanks for joining us for our industry presentation series. We will be recording this session. I'm delighted to tell you that Viktor is presenting today on tools that run modern software. Viktor Semenyuk is the lead software engineer at AV Node Group, where he focuses on building and refining aviation software. He also has a side gig with Geologic LLC, that building a logic optimization platform for the aggregate industry. He enjoyed blending hands-on technical work with mentoring and community initiative. He's passionate about sharing real-world industry insight with future engineers. Please join me in welcoming Viktor.
Thank you, sir. I'll start a screen share here and we'll run through tools that run modern software. So the way I structured this presentation is more for engineers just entering the industry. It's more structured around what you would expect on your first week of work, your second day. What do you do jumping in? So we'll run through that and yeah, give me feel free to shoot out any questions if you have them. So a quick intro, we're going to talk about project management tools, development environments, your continuous integration and continuous deployment tools that we use, and then what type of tools you might use after you've released the application or released your code to production. How do you analyze what's going on? So day two on the job, what are we expecting? We'll cover how software projects are managed, how code is written, tested, and deployed, who determines what is built, when, and the process around that, and what do teams utilize to stay organized. So to start kicking this off, let's talk about project management. Before we go too deep into project management tools, I wanted to cover a software development lifecycle. When we're shipping code to production, it needs to be very much structured. We need to pre-plan the features that are going, and we need to understand how these features interact and how they will work with um, the rest of the application that's already part of production, part of what users are utilizing. We want to ensure that we're not degrading performance, we're not breaking features and introducing regressions. So project planning is highly important. We have product teams that will take a look at users' feedback of our existing software, and they will plan feature roadmaps. These features then go into a design phase and a ticket creation phase. During the design phase, the UI and UX experts at our company will create visuals and create what this feature will look like and how the interaction will work in production. And then team leads jump in and break out that functionality into smaller bits and pieces. We then put these user stories, these very minimum deliverables into tickets. And these tickets get passed on to certain developers. Developers pick it up. After the developer picks up a ticket, the ticket contains information. We'll cover what a ticket is in a second, but it contains information of what needs to be built. And developer will go through that process, give it off to test to QA, and QA will say, yes, this meets the expectation of the product, or no, this does not. If it does not meet expectation, it goes back to the developer, and the developer will iterate on it until it meets that expectation. And when it does meet the expectation, it will go into the deployment process. So let's talk a little bit about what a ticket is. Let me take a look here. So here we're taking a look at a tool that we utilize. We're using a ticket tracking system called Jira. There's a few other tools out there, but with this tool, product teams do their planning in here. Developers understand what needs to be done, and also move individual units of work through different swim lanes to show progress of where they are at. So the ticket might start in next up. Product will groom it and get it ready for a developer to pick up. Developer will pick it up from the next up column, put it into in progress, do some work, write some code. And when they think that the code that they've written meets the criteria of the ticket, they will move it ready for test. Here you could see I moved, let's take a look at this ticket, 2543, add Pendo tracking to reorder list interactions. This is a ticket that I worked on last week. It was in my in progress. Now I moved it to the ready for test column. Whichever QA tester is available next will pick up that ticket, pull it into the testing column, run their test analysis, and ensure the work that I've done meets the criteria the product owner has written. And as soon as that work passes QA, they will move it into the ready to release swim lane. So what is the ticket? A ticket is a description of a feature or part of a feature that needs to be developed. A ticket describes the functionality, and the acceptance criteria defines what needs to be tested. So you can think of it as a acceptance criteria is kind of a contract between product development and QA. Uh, Product will write out what needs to be developed, developers will build it out, and then QA will verify that the functionality that was built out is what product initially defined. So that's part of what happens during QA testing. And uh, yeah, that's essentially what a ticket looks like. Here's an example of that same Pendo tracking ticket. You could see my product owner wrote out that we need to add tracking events to the code base so that we could uh, understand user intent better. This will help us plan future features around this specific functionality in the application. And allow us, to modify the UI to improve the UI. So I added a few events as the reorder tabbed, as the reorder move section, as the reorder commit, and uh, let me let me quickly show what this looks like. I'll share my screen again. Oh, I shared the wrong thing. Let me share the simulator. Here it is. So I've built this feature in production. Here's the application I've been working on. This feature lives behind this reorder section. So my product owner said, anytime that a user does this interaction and moves a certain section to a different location, which reorders this parent page, we want to track that. And the reason we want to track that is we want to understand when a pilot jumps into this page, we want to understand how they utilize this page. Adding these track events helps us understand, oh, the pilots want to see the itinerary as the first thing, and then they want to see, information about the aircraft next, whatever else type of information like this. So the ticket was very much based around that, um, asking me to introduce track events so that we could uh, analyze and improve this for our customers. Okay, let me get back to my slides. So this ticket is ready for test. We're waiting for QA to take a look at it. When else do we use this Jira board? So we utilize this Jira board quite a bit during our stand-up meetings, and a stand-up meeting is something that occurs every single day between the development team. Individuals that join the stand-up meeting are developers, product owners, QA, usually management as well. It's a quick 5 to 10 minute session where each individual talks about what they've done yesterday and if they are blocked on anything and what they're planning to work on today. Uh, this helps the entire team to be on the same page of who's doing what. And if I need to jump in and support somebody, I can do that. People will usually voice any sort of concerns that they have or any support that they need. And it's usually a good place to voice um, problems that you might be having. Maybe your environment is not working. First day on the job, or second day, you might need to voice your concerns and say, "Hey, I'm blocked here. I can't continue working on this assigned work for me." So that covers the project management section and the tools that we use for project management. Next, we'll jump in and talk a little bit about development tools. Um, I heard you guys are familiar with Git, so I won't go too far into Git, but I'll cover it surface level. It's a repository of the directory with history. Just understand that any change that you make within that directory, within those files, Git will track it, attach your name to that commit, and whenever you push those changes, other developers will be able to see who made those commits, when they were made, what part of a feature they joined the code base with. That helps us with tracking through, like if an issue was introduced, it helps us understand at what time, with what release, with which commit um, was it introduced, and it really helps us uh, fix and either revert that commit or push a patch onto that commit and send a release to production quickly. Helps us understand what's going on. In terms of IDEs, I'm pretty sure you guys have used text editors, text editors plus compilers. That's usually what an IDE is. I use quite a bit of VS Code if I'm writing anything in Python or C Sharp. And if I'm writing anything in Objective-C or Swift, I'm utilizing Xcode. That's Apple's uh, integrated development environment. And more recently, I've been utilizing Cursor. Cursor, it used to be an extension on top of VS Code, but now they've released their own IDE, which is based off of the open source project for VS Code, but has integrated AI models that you could utilize. You could hook up your uh, Chat GPT subscription or your Claude subscription, whichever AI model you have. Cursor will analyze your entire project and give you suggestions. So it could be a very useful tool. If you guys are not using it, I recommend taking a look at that. Um, it helps understand what's going on in the project. Mostly the way I utilize Cursor is when I jumped into the project, we've had other developers that written code, and for the most part, it's well documented, but sometimes, the code is just ancient and you want to understand really what's going on. I'll highlight certain areas of the code and I'll ask Cursor to explain to me, hey, what's going on in this code? Uh, is there any recommendations or suggestions you would recommend in improving this code? Cursor does a pretty good job making those suggestions, but you also got to be wary and understand when it's going a little too far because it could make changes that you don't want to ship in production. It could introduce um, bugs or regression if it modifies code that you didn't want it to touch. I also mentioned GitHub, GitLab, Bitbucket here. These are web interfaces to represent the repository of what you're pushing to it and what other developers are pushing to it. I'll jump into a quick demo a little bit further on how we utilize GitHub and how we utilize pull request process and the process of development. But yeah, it's essentially a web repository where you can see uh, the state of the code base and all of the files. Other development environment tools that we use package managers. These help us install different libraries into our application code that has previously been written so that we don't have to reinvent the wheel. There's a lot of well-supported libraries out there, third-party code that's open source, that's free, that's supported by the community. Usually you would bring that into your project utilizing some sort of package manager. For iOS, we utilize CocoaPods, and more recently, there's a native built-in Swift package manager. So if you're writing any iPhone apps, you'd probably be utilizing CocoaPods or Swift package manager. There's also tools that we use to track reliability and performance. Uh, for us, it's Firebase. uh, it's a tool that used to be called Crashlytics that Google acquired and branded under its own uh, Firebase tools. What allows us to track is if we introduce some sort of crash or some sort of performance degradation into production, Firebase will alert us and send us notifications directly into Slack or into our email so a developer can take a look at it quickly. As soon as it occurs out there in the wild, we can't get the user device and analyze what's going on with the app, what issue is going on. That's where Firebase is very uh, fundamentally helpful for us because it's able to pull that crash that happened and send those logs up to the developer so the developer can open it up and take a look. And I'll cover the CI/CD tools a little bit more in detail, but CI/CD tools are definitely something that we use that's part of our development environments integrated. So here I'll talk a little bit about the process. You you've joined a company, you've got access to the to GitHub. They've given you access to the repository that you'll be working with. You'll clone that repository. Usually you'll start with creating a work branch, and work branches is your feature branch where you'll write most of your code. And once you're done writing your code, you'll push that branch up uh, to remote, or another word for it is origin. But essentially, what it does is it pushes it up to the server in GitHub. It doesn't do a release yet. It just pushes your local changes from your machine up to GitHub. And once you've done that, in our process, we'll go and we'll open up pull request. Pull request is um, an interface that GitHub provides for another developer to review the changes that are being made to the code. So at stage number 6, another developer will jump in and start taking a look at my changes and say, okay, Victor made these changes to these files. These look okay. But I have a concern here. So the developer might leave a comment. If there's no correction required, then that code is ready to go into QA. If there's some sort of correction required, that will be flagged, and me as a developer, I'll need to jump back in, fix up any concerns, any comments that were left on that PR, and then send it in for review again. So here's a similar representation, but more showing the different developers. So developers will be doing the work. They'll push it to GitHub. That will go into code review. Once it passes code review, it will get merged into production and then a release off of, well, it will get merged into the master or main branch and then a release off of the master or main branch will run. So what we'll do is we'll jump into a quick demo. What I'll do is I'll open, well, maybe I don't need to create a Git feature branch since you guys are familiar with Git, but I will show source tree because it's a tool that we utilize. You guys may have utilized it before, uh, maybe not. I know when I started as a developer, it was very useful for me. A source tree is basically a visual representation of what you might be doing in Git in your terminal. In here, you can pull different branches. So I might pull this branch that I'm working on right now. There was an update in Origin that I didn't have, so I just pulled it. I sent a beta release. So that's the change that I pulled. I can fetch, I can branch, I can create a new branch off of the one I'm on right now, or I can do a merge of this existing branch. We usually don't do merges through source tree. Merge for us only happens through the pull request process. So let's jump in and take a look at a pull request real quick. Do you guys still see my screen for Safari? Yes. Okay. So this is that beta build that was going up. GitHub is being stubborn. But yeah, here in GitHub, I'll open my pull request tab. As a developer, you'll probably jump into here, open a new pull request. You're merging something into master. Here you will select your branch that you're trying to merge. In this case, this branch has already been merged, but I'll take a look at the um, analytics ticket that we were looking at earlier. So that analytics ticket from Jira ends up in GitHub after I've done the work. And here I can take a look at the files changed. Here's the code that was modified to add those analytics. And now we're tracking it. And here my coworker Alex left a comment on a potential improvement that he thinks would benefit us better. So as a developer, I'll jump in here. I'll take a look at the PR. It did get an approval. So the comment was like, "Hey, it's nice to have, but I'll approve it if you don't have it. It will still work as is." So he marks it with a ship icon, usually meaning it's ready for ship. But that doesn't necessarily mean it's all good to go. Here I have a few checks that run. I have a unit test that did pass. I got a green check on that. But I also have a UI test suite that needed to run, and this UI test suite just completely failed, which means I need to come in and fix some things up in this branch to ensure that both UI tests and unit tests are passing before I can merge this branch into master. Um, Merging the pull request through GitHub will do the same thing as running git merge in your local branch into master. We block, and most companies do. Most companies and that have code in production, they block the master branch so that a developer can't push to it directly. And the only way your code can make it into master is through a pull request. So that's the process we have in our company as well. Um, yeah, let me stop this share, jump back to the presentation. So we talked a little bit about source tree. We talked about a bit about the PR approval process and what's required there. Let's start, let's take a look at continuous integration and continuous delivery tools and how they are utilized. So I covered it a little bit. You guys may have seen those green checks and the red X on the unit test and UI test suite. Whenever you make a commit into your branch and there's an open PR with our process, we will run a few things. We will build the application to ensure that it can compile, it can build. The next thing we will do is we will run a various amount of test suites around it. Sometimes we have integration tests, sometimes we have UI tests, uh, and unit tests. Unit tests run every time, UI tests run every time, but integration test suite runs before we do our release to production. Um, Yeah, these results are reflected through GitHub, so you can see, oh, my test passed, or no, my test failed, and let's take a look at what failed there. So I'll actually jump into that as well, and we'll take a look at the test runs. I actually think we just did that, but let's take a look. Let's take a deeper look at this test run. So we'll take a look at the unit tests. So this is an automated script. It runs through a workflow file whenever a pull request is open. These are workflow files that you could set up in GitHub Actions through GitHub. And whenever a commit is sent, all of these different stages run here. And I'll open specifically the test script side. We can see that we're doing build, we're doing a compile of the application. And at one point here, we're going to start running tests. So a lot of this is just DLI output to get to the test portion. So here we got to the test portion. I skipped it. So here's our test suite. Every single class, uh, well, for the most part, every class that has functionality that needs to be tested, we write unit tests around it. And you can see here it says, okay, we tested flying pilot crew ID and it took 0.1 seconds. And then we tested single pilot is landing is take. So every one of these is the test scenarios that I wrote when I was introducing the feature, or my coworker wrote when he was introducing a feature. And as we ship features, these unit tests and UI test suites, they grow and grow and grow, and they get more tests. So currently we have, I think, around 400 tests. Yeah, 400 tests that run. So 400 tests ran, 397 ran, zero of them failed. So we know that this test run was good. We got the green check on it, and we know that we didn't introduce any issues with this code and in, into this branch that we're going to be merging into master. So that's important. We also run UI tests. So here we'll take a look. Um, Very similar process. We are just running, instead of running the unit test suite, we're running the UI test suite. Let's take a look. So for in my branch, test UI was failing. In my coworker's branch here, test UI is passing. We can see a lot of UI tests run, and these take much longer because what it does is it brings up the simulator like I did, and it goes through and taps through the application and makes sure different portions of application are working as expected. So that acceptance criteria that you saw in the ticket, I will take it as a developer and I will write a UI test case around it. My coworker will do the same, and that will increase the amount of tests that we run. So we have 129 UI tests right at the moment that are running for the iPhone, and then another 129 that are running against an iPad because the UI interfaces are a little bit different. So these two suites run, and when we get those green check marks, we're good to go. The reviewer knows, hey, test passed. I feel confident merging this in. I feel confident approving it outside of just reviewing the code. So that's part of the CI process, continuous integration. So anytime you make a commit, you can see it here. There was a commit and then tests ran. You can see on this commit, the unit test passed, but the UI tests were failing. And then well, if there were more commits, you would see more commits and a response for each single one of them. So that's the continuous integration. Every time you commit into a PR, some test suites will run, and you can write whichever scripts you want to ensure that those tests run. Or you can write something else. I'll give you guys an example. So outside of just our unit tests and UI tests, we do Firebase beta builds. So this is where I don't want the code to go to production yet, but I do want to distribute it so my QA testers can test it. And for this, I need to run something we call a beta release script. So before it would take like 14 minutes, 17 minutes, and before I would need to run it on my local machine. And the same thing with unit tests and UI tests. I would need to run it on my local machine. And you could see how much time that takes from a developer. Instead of being able to utilize his local environment to continue writing code, working on another feature, I would need to wait for the unit test to pass or the UI test to pass, and that would take up to an hour. Now we just push it all up to the cloud and it runs on a server somewhere, and then it gives us the result. Same thing with a beta release build. I wrote a script that when I run this Firebase beta release script, let's run it on a specific branch that I was working on. I can start run workflow, and this workflow will start running. It will check out my branch for that code. It will set up the job, check out the branch, uh, make sure that everything builds and runs. Um, and then it will start a deployment process for it. It'll start a deployment process, run the deployment, give me a version number of the release, and then I can take that version number and give it to QA. So this will take around 17 minutes to run, based on these other beta builds that we see here, 14, 17 minutes. It depends on what server you hit and how beefy it is. So Firebase beta release, and then we do the same thing with App Store. When we need to push something to App Store, we'll jump into here and we have scripts that are already written. The reason we do that is because different developers might have different environments locally, and when they're sending a release, their environment might differ a little bit from my environment. But if we're all sending a release from a server, the way we wrote and structured those scripts are always going to be the same. So it doesn't matter which server it runs on, it doesn't matter which machine it runs on. This continuous deployment part of the workflow, it will always be the same thing. It will always pull the code, it will always do a clean, it will always run the unit test, make sure that it's using the proper certificates, and then send that code up to Apple for release into the App Store. So that's another major benefit. Like aside from just saving time, developers not having to run this on local machines, um, it also has a consistent release environment. So there's less chances of introducing some sort of issue. After we do an App Store release, there's some TLC that we need to do. So I would need to jump into here, take a look at each one of these tickets from my Jira board, and mark it that it's been released. Give it a release version. Um, I became a bit lazy and didn't want to do that. So what I did is I created a Jira release job for it. And what it does is it runs in 24 seconds. It took me half an hour to write, but what it does is it connects to our Jira over an API, pulls all of the tickets that are in the ready to release column, and then it understands which PRs got merged, and it will go through and assign a version number to every single one of those tickets and change the status of that ticket that's been released. So instead of me having to go in there and modify all of the 12, 15 tickets, how many ever went in the release, I just jump into here, hit run workflow, and whatever tickets got shipped, it will go through and do all of that work for me. So see, continuous integration, continuous deployment, these type of scripting tools, they help you quite a bit. And they run on your repository, and you can hook them up with different actions, create workflows, and there's even workflows that exist out there. GitHub has like a marketplace where you can start if you're looking to do, I don't know, I don't have a good example. If you're looking to run like a linter, or if you're looking to run some sort of specific tool, if you're trying to deploy to Amazon ECS, because they already have like specific scripts configured for you. You just need to jump in there and modify a little bit to work for your specific repository, and then that work is automated. You don't need to manually go and do a deployment to Amazon ECS. You can use a deploy script action that you trigger from your repository. All right. I think that's it for the CI/CD portion. Let me jump back into the demo here, or into my presentation. So we talked about a PR and test runs on the PR. We talked about a beta release script, getting QA to test your code, and we talked about closing out Jira stories after they've been released to the App Store. Um, let's take a look at what happens after we've deployed. After we've deployed to production, as I talked a little bit about previously, right now the way I debug an application is I have to plug the phone into my laptop, run it with Xcode, and see the stack trace. If a bug occurred, if something happened, if something broke, I I can debug that by you having the phone plugged into my computer. But if a user sees this issue, it's really hard to debug because we can't have users bring their phones and plug them into my laptop. So we utilize different analytics and performance tracking tools. So for that specific issue that has to do with our binary, we'll usually use Firebase. If some sort of issue occurs, Firebase will pick up those DSIMs from that specific build and send it to us as a developer and say, hey, you have an issue here. We're realizing that there's some sort of crash. You probably should go and investigate. I'll jump in and I'll do an investigation, take a look at the stack trace. If I find something, I'll ship a release. Some other tools we utilize is New Relic, Datadog, or New Relic and Datadog is a different tool. What this helps us see, these are more like server analytics tools. They help us see not stack traces, but network traces, understand oh, the users are hitting a lot of 404 errors when they're making this API request, or this API request takes much longer than usual. So when I'm shipping a feature, I'm usually working in a combination. It's me and a backend developer. Backend developers building functionality that will provide data into the app. So understanding if something was introduced, not just from my end, but maybe also from the backend side, New Relic or Datadog, these type of tools will help us track that down and be able to catch an issue. Maybe even before the users see it, we could get an alert and say, hey, this endpoint is underperforming. Something you guys did, something you guys released may have broken something. So it's like a early warning system before the user does a report. We're able to see what's going on. And the last of these analytics tools is more on the UX analytics side. We use Pendo. There's also tools like Clarity. Clarity is a Microsoft tool, free to use. They say forever. What Clarity does is it actually takes screenshots of what the user is doing in the application, either be it web or be it a mobile app, and it will compile you a timeline of the user's experience as they're navigating through the application. Very helpful if you're trying to debug an issue that a user is reporting, but you can't reproduce. You can find that user by their ID, jump into Clarity, see a video of what they were doing, what their interactions were, and really follow through step by step. For us at Avinode, we're usually utilizing Pendo, and with Pendo, we don't quite get the screenshots of what's going on, but we do have a lot of event tracking, and I'll jump through and show you guys a quick demo of those tools as well. So here we go. So here's Pendo. I'm taking a look at a specific event here for my demo company for our product. So here we're doing a flight log v2 fetch. So we have a different version of flight log. We want to know how many times the user fetches that flight log successfully. So here we can see some analytics over the last 30 days. We can see, okay, my test account has been sending this event for 27 times on some days. We're getting 6 unique visitors on the demo company taking a look at this. Overall, 148 events, 60% of the users that are visiting this page or adoption is 60%, 6 out of 10 users that are using our app are visiting this page for the demo company. What's really cool is I could jump into a specific user. Here's my test account, and I can open up the timeline for my specific account. So let's take a look at that. So here, and I'll talk a little bit about why this is important. So I'm zooming in on specific events. So the application sends specific events of what occurs, what different views are being touched, what different network requests are being made, what actions the is doing. So these are track events that we send from the application, and Pendos collects it all and stores it. And then when a user reports an issue and says, "Hey, around 9:02 p.m. I was seeing this issue," I can jump into here, find the user, open their timeline, zoom in on what they were doing around 9:02 p.m. and try to reproduce the steps that they took to see that specific issue. And I might even find an issue there, like maybe handle app tokens here. It was false. So maybe they had a login issue and they needed to re-authenticate something. This will help me trace down like specific to to the to the second of what was going on, and it gives me as a developer insight into what's going on in production. So Pendo is a very powerful tool from that sense. And on top of everything else, we looked about feature events. So like we'll see feature adoption, how are users utilizing our app and this feature that we just released. So it's quite a powerful tool. I talked a little bit about Firebase Crashlytics. So I'll show this UI as well. So here's a crash that one user experienced over the past 30 days. So I'll take a look at that. I'll open it up, and right here I can see a stack trace. This issue seems to be going on with the Wootrick SDK library, which is some third-party code that we pulled in, a tool that we're using. Not much I can do about it, but it shows a stack trace of what's going on, a crash that happened, and it allows us to jump in deeper and investigate what is the issue, try to understand what's going on there. So that's a little bit about analytics and post deployment. Um, yeah, that's these are the tools that you might use on your first week of work. You might need to get familiar with them. The post deployment tools are quite important, especially if you introduce something and it's a fire drill and it's like, oh my gosh, customers are reporting all of these issues. And it's kind of a chaotic moment when that happens. And for me, what I do is I open up New Relic, I open up Pendo, and I open up Firebase, and I go through each one of them, and I narrow down the scope of the issue. Okay, Firebase is not saying that anything is crashing. It's the overlap of all of those tools that helps you narrow down where the issue is occurring, and then you from these tools you jump into GitHub and you try to narrow down, okay, which commit, which feature was shipped, oh, that introduced this issue, and then from that commit you're like, oh, okay, here's exactly the code change that introduced this issue. Let me make a fix on it. Make a fix, you push it through your development process, it goes through QA, it goes through deployment, it gets automatically deployed to the App Store, and within, you know, 6 to 8 hours, you have a fix out in production. For us with iOS apps, it takes around 6 to 8 hours because Apple needs to approve the release. But with web, it could be instant. Within 20 minutes, you're going to have a release out and your website's going to be back up and running. So just depending on like where you're going to go with your career from here, you're going to be using very much similar tools, and having familiarity with them is a good thing. I'll open it up to questions. If anybody has any questions, feel free to ask.
While people are thinking of their question, I'll jump in there and ask a question. Can you hear me?
Yeah.
Okay. So you talked about unit test and UI test. Do you have tools that make that happen, or you as a developer has to think about, hey, I created this event with this functionality, and the typical limits of inputs are these kinds of input, and typical expectation is that, and you just force it.
That's a great question. For the longest time, I, as a developer, needed to do that. I'll jump into Xcode and I'll show you guys real quick here. We have different tests. So here's our UI test. So I wrote some duty log UI tests. It's something that I had to write. We built up a lot of mocking infrastructure around it. And maybe this is a topic that I could go a little deeper into another time. But our UI tests don't hit production servers and they don't even hit test servers. We need to mock up a lot of that data. And then I'll create specific, I guess, UI simulations of what's happening. So I need we have a feature where pilot can submit a duty log. So I'll create and submit a duty log, and this is the UI test that runs for it. I'll set up the mocks and then do specific taps in the application. And you can see all of these files contain UI tests, and a lot of that we have to write manually. So or AI has definitely been beneficial here. I'll write a feature, and if UI has access to my views, it might understand the UI I'm trying to build around, and it can suggest different test cases for UI. It's definitely much better for unit testing because it understands logic. Unit testing usually doesn't touch any of the UI components. So any classes that we have, I can ask AI to write some unit tests around it, and it usually gives me a pretty good unit test, and then I'll jump in, make some modifications, and it'll be good to go for my PR.
Thank you. There was a question on the chat. I don't know if you can see it or you want me to read it.
Sure. How does integrating the post-development tools work? It's a great question. Um, in your development environment, I talked a little bit about package managers. Usually, somebody like Pendo has their own iOS developers or their own web developers that will build up these packages, and they will do version deployments of them. And then me as a developer at Avinode, I need to pull that package into my project and compile it. And there's unique keys that identify the company. There's unique keys for our development. As you start paying for this product, Panda will provide you those keys. You will initialize the libraries with it, and then you'll ship that into production. And Pendo's code will be living with your project, and you'll be able to track events and track different issues that happen. And it's the same thing with Firebase and Google Analytics and New Relic. All of these, they have their own um, packages that they publish on package managers. They have it on Swift Package Manager and Cocoa Pods that you can pull it into your project.
I don't see any other question. Maybe one more, just since you're here, I would ask another question. Well, maybe somebody's thinking of some other question to come up with. Um, as someone who is just trying to look for a job and you're a new engineer, or do you have some recommendation for them how to be successful in today's environment? What should they be ready for?
Yeah, that's understanding what your workday will look like, understanding what CI/CD is, understanding how a development process works. All of those are um, questions that will be brought up in an interview. So if you're able to prepare through, I don't know, watching different industry presentations or watching and understanding how this development process works, you'll be able, even if you don't have the direct experience of working with it, you'll be able to at least talk about it and have talk about your understanding of it. When you're looking for more of a junior position, um, management and engineering teams don't expect you to know everything, but at least understanding the terminology and the basic concepts of it is important. Um, I remember when I was doing my first interviews, it was a lot of notes and a lot of studying on just how a development process works. Even on my first day at work, it's like, okay, where do I go? What do I do? The development team was like, oh, we're doing stand up. Okay, like you're a little bit lost, but then you get into the groove of things and people help you out. And usually when you get into a team, one thing I'll mention for sure is like don't be afraid to ask questions. Everyone's been there where you are on your first week of work. And if you're having trouble, if you're struggling a little bit, ask questions and developers are always open to helping. In terms of finding those type of jobs, it was a little bit difficult here for a while, especially with a lot of the AI hype. Many of the companies were saying, "Oh, AI is going to replace junior developers," and yeah, maybe it will for companies like Facebook. Maybe it will for massive companies. The issues that Facebook doesn't care about is that they can get developers from other companies. But small companies, they will always need junior developers and they will always need those mid-level developers. It's not going to be replaced by AI anytime soon. So that brings a little bit of comfort. And a lot of senior engineers that I've talked to said senior engineers are very good at using AI because they understand the concepts, the architecture, they understand when AI is giving them results that are not correct. But in order to have senior engineers, you need to have junior engineers because junior engineers upgrade into becoming those senior engineers. So there's always going to be junior engineers. There's going to be positions out there. Um, Try to make those industry connections. If you're looking for a job in a specific if you want to become an iOS developer, Portland has a lot of iOS developer meetups. I think if there's like three of them. I say a lot. I think there's like three of them. If you're trying to become a React Native engineer, there's React Native meetups that happen in Portland. Maybe start attending them. You'll make connections with other engineers that are already working at companies. And when positions do come up and you have a good connection built up with those individuals, you'll be first one to know. So a lot of it is about human interaction and making those connections. And you do that by joining the events that
And
happen.
attending meetings, right? Attending presentations, being active participant in those meetings.
Yeah,
Well,
that's true.
any other question for Victor? Well, thanks, Victor. A very informative, engaging presentation. Thanks for taking your afternoon and coming and talking to us.
Of
Um,
course.
Everybody else, if you know of a person you or a topic you want to hear from or about, please let me know and we'll do our best through Victor and through other people who are helping us. We'll try to figure out the right person to come and talk to us. Thanks again, everyone. I hope you guys have a great weekend. And thanks again, Victor. Have a good
Thank
night.
you very much, sir. See you.